This presentation is on the Pythagorean Theorem, which says a squared plus b squared equals c squared. Keep in mind that the Pythagorean Theorem can only be used with right triangles and that c, or the side by itself on the equal side, must be the hypotenuse. So the legs of the triangle, or the sides that make the right angle, are a and b. Okay, let's say we need to find the hypotenuse of the triangle. The hypotenuse, if you remember, is the side opposite the right angle on the triangle. So in this case, it's side C. We use the Pythagorean theorem, a squared plus b squared equals c squared, and plug in 4 and 6 for the legs a and b. So we say 4 squared plus 6 squared equals c squared. And if you switch the 6 and the 4, it doesn't matter, it comes out to the same answer. So 4 squared plus 6 squared ends up being 52. So 52 equals c squared. Now you take the square root, and c is equal to the square root of 52. And that is about 7.211. Now let's say we have a right triangle where we know one of the legs and the hypotenuse, and we need to find out the other leg. We still use the Pythagorean theorem, which says a squared plus b squared equals c squared. The only difference is, this time we're trying to find a leg. So we can choose that leg to be either a or b. I'll let it be a. So we say a squared plus 14 squared equals 35 squared. The next step is to get a squared by itself. So we have a squared equals, and it's 35 squared minus the 14 squared. And that just ends up being 1,029. You can type that in on your calculator. 35 squared minus 14 squared. We then take the square root. So we have a equals the square root of 1,029, and that is about 32.078. Okay, let's say I need to find two sides of the triangle, and I know an angle and a side. There's two ways to do, and only one of them uses the Pythagorean theorem, so that's the one we're going to use today. In either case, first we need to use trig, and we can use trig to find either side A or side C. I'm going to find side A. To find side A, we're going to be using the tangent function, because that equals the opposite over the adjacent, or 12 over A. When we do this, we end up getting that A equals 12 divided by tangent 35. And if you forget how to do this, you can see the SOHCAHTOA video in Moodle also. Once we get A equals 12 tangent 35, or about 17.138, we can use the Pythagorean theorem to figure out side C. Now, when I plug in the Pythagorean theorem, I'm not going to use the 17.138 for A. Instead, I'm going to use parentheses, and I'm going to type in 12 divided by tangent 35, and I'm going to take that whole thing and square it, and then add that to 12 squared, and solve for c squared, or the hypotenuse. The reason I'm typing the 12 divided by tangent 35 in is because it's more of an exact answer, and we want to round as little as possible. anyways, after I type all this in, I get that c squared is about 437.703. Or c, I'm going to have to move over here, is the square root of 437.703. And that's because I had to take the square root of both sides, and that's about. And when I type that into the calculator, c is about 20.921. And that is how I use trig and the Pythagorean theorem to find two different sides. And that is the end of this tutorial on how to use the Pythagorean theorem with right triangles.